We're complete. We're done with radicals and now we go back at it in grade 11. So I'm sure some of you are happy to hear that. Today, I don't tend to use algebra tiles if it's really necessary that you don't understand how to multiply polynomials together, which we'll talk about in a minute. Then there's something that I can certainly look at. First thing I want you to do, let's just write some things down so that we understand what we're working up to is being able to multiply binomials by binomials and trinomials by trinomials. What that means is this is considered a binomial because it's two terms separated by one either plus or add or subtract sign. So it's considered a binomial. If there are three terms separated by two add or subtract signs, then it's considered a trinomial. All right, so looking at this right now, what do I do with that 3? Multiply it. And what does it work out to when I multiply this up?
3a plus 12.
What is it, sorry?
3a plus 12.
Very good. Thank you. 3a plus 12. So we all understand what the distributive property is. And that is, when you have it on the outside of the brackets, you multiply it in the brackets, and you multiply it by everything inside the brackets. We all agree with that? Yeah? Okay. So what we're going to do is, we're going to take a little bit more extreme examples. So let's try one more. Okay. So I have 2a on the outside of the bracket, multiplied by a plus 6. What does that equal? Go ahead, David.
2a squared plus 12a.
2a squared plus 12a. Do we agree or disagree? How many of us agree with that? Anybody disagree? Who doesn't know?
Well, 2a and 6 are two separate numbers, so they can't be added.
I didn't add them.
But it's like, it wouldn't be like adding apples and oranges, what they say, because it's two different things, or no? Is it like,
All right, so that's a very good point. But what you have mixed up is I'm not actually adding these. I'm multiplying. I am allowed to multiply anything. Okay? I can change an apple to an orange, so to speak. I can take an a and I can change it to an a squared. I can do that as long as I'm multiplying. I can also do it in division. I cannot add or subtract those together. So this remains as 2a squared plus 12a. I cannot add these together and get something simplified. They just remain as 2a squared plus 12a. Does that make sense? So if you're multiplying, you can change. If you're adding or subtracting, they have to be exactly the same. Yes, sir.
So how does it end up squared?
Well, what does a times a give you?
Oh, okay, I see now.
Okay?
Yeah.
Make sense?
Yeah.
Good. All right. So I'm trying to go through smaller ones. So let's try one more here. Let's go 3a. This time I'm going to multiply it by a trinomial. A squared plus 4a plus 5. Okay? Rory, go ahead.
A squared plus 12a plus 15a. Or would you add the 15a plus 12a?
Okay. Let's start at the beginning again. What did you say the first was?
A squared.
A squared, do we agree? Yeah?
No.
What should it be?
3a.
No? All right. Okay, so there's the first question. I'm not gathering like terms yet. I'm multiplying through first, right? I'm multiplying through first. So the first thing I need to do is take 3a and times it by a squared. So let's deal with the 3 times 1, because essentially that's what's happening. What is 3 times 1? So I do need that 3 there. That has to be there. What is a times a squared now?
A squared.
A what?
A squared.
A squared?
A cubed.
A cubed. Which one is it? All right, we just finished a whole section on exponent laws, did we not?
Yeah.
What do I do when I take a times a squared? What do I do with the exponents? I do what? What do I do, Shay? I add them, right? What's the exponent on this a? 1. What's the exponent on this guy? 2. And what do I do with them, Shay? Add them. So what is a times a squared? A what? Cubed. 3a cubed. Do we follow that? How many a's are here?
1.
How many a's are there? How many a's total?
3.
3. Right? Okay, so far, so it is 3a cubed. All right, now, let's go back to this. 3a times 4a now. What is it? Now we're catching on. 12a squared. And then what was the last one, Rory? 15a. That one was right. You see your errors? Okay. Are we good? Okay, we're getting it. All right, let's try again. Okay, write it down on your own piece, on your own sheet right now, and see if you can come up with the correct solution. All right, somebody not named Rory. Morgan, you want to have a go?
3 cubed, negative 3x to the square plus 6x.
Okay, let's start with that first guy again. What did you say it was?
X cubed.
X cubed. X cubed. We agree? Yeah, I think so too. And then you said this was?
Negative 3x squared
Awesome. And?
plus 6x.
Way to go, Morgan. You nailed it. How many of us got it right? Okay. Who had an error here? Which part did you have an error, Cole?
I didn't put 6 x, but
You just had what there?
I just had 6.
6? Okay, so you realize that when it's on the outside, it's multiplied by everything on the inside. Okay? Who else had an error here? Anybody else want to fess up? Don't be shy. It's easy for me to teach those errors. You had an error? Okay? So that's the other thing. All right, I'm going to change that in a second here. Okay, I'm going to change this up. Everybody else was okay with this guy? All right, here we go. Okay? Two of us. Put up your hand when you're done. Put up your hand when you're done. So I can have a look, make sure everybody has a chance to do it. Your hand up when you're done. Okay. Good. All right. Everybody's good, I think. Okay. Who wants to have a go? Brandon, go ahead.
Negative x cubed minus 3x squared.
Negative x cubed minus 3x squared. Who wants to agree or disagree with that? Who agrees with it? Put up your hand. Who disagrees with it? Put up your hand. What do you think, Dylan?
I thought you'd go negative 3 or x3 plus and then in brackets negative 3x.
Okay, tell me that again because I think you got the same thing. Did you say negative
Pretty
x
much the
cubed
same. Yeah, negative x cubed.
plus, and then in brackets you had a negative 3x? You have the same
I
thing.
had the same.
That's the same thing. Okay, if you have an add a negative, it's the same as subtract. Okay, so you have the exact same solution. All right, so that's good. The biggest thing, the number one mistake that gets made by students doing this is forgetting that that negative has to change both the terms on the inside of the brackets. You have to change the terms by transferring that negative through the brackets. Okay, and that's the number one mistake that gets made. All right? Are we okay so far? Because I'm about to take this a little bit deeper here. Okay, I have a separate question to ask you right now. Without a calculator, I would like you to do this. Without a calculator, on your paper, you can use your paper. I would like you to multiply these together, please. Okay. I know you may not be finished. How many of you in here stacked that? Okay. So you put it as 321 over 54. Do you agree? Is that what you did? How many of you did that? Okay, so there is other methods. I get it. I'm hoping that most of you did this method, so I'm going to show it to you. And I have a very good reason for that in a second. So I have 321 times 54. So now what do? How do I multiply this? 4 times 1, 4 times 2, 4 times 3, agreed? And then I put an X right here, right? And then 5 times 1, 5 times 2, 5 times 3, add 1. We all agree? Okay, great. 4, 3, 3, 7, 1, right? And I just add them together. Okay, so how many of us did this method? I don't care if you got it right or wrong, just how many of you did this method? Okay. We're going to multiply a binomial by a trinomial now. And I'm about to show you 2 methods in which you can do it. And the first method is actually this exact method, stacking method. And you follow it the same way. That's why I like to show this. This is how you were taught to multiply in elementary school. You were taught to stack them, multiply starting on your right, working your way across, carry your numbers, whatever. This is how you were taught to do it. So I'm about to show you how to multiply a binomial by a trinomial by using this exact same method. That way, if you know how to do this, the next method will be just as easy when I do it. Okay? So it works like this. Take a look at page 86. It's asking you to multiply 2a plus 4 by a squared plus 5a plus 7. Now I'm about to show you 2 methods in order to solve this, okay? And we actually have already done method 1, but I'm going to go back and show it to you this way. So here's what I'm going to do. I'm going to write out a squared plus 5a plus 7 on top here. A squared plus 5a adds 7. Okay, so this is something that you want to write down and follow as I go and ask if you don't understand. Then I'm going to put 2a plus 4 right here. Okay. So write it out like that just to begin with, okay? Now there's one major difference between what I just showed you here. On this guy, I started on the right and I worked my way left. Okay? I'm going to do the opposite here. It would still work using that way. But I'm going to show you the opposite way. I'm going to start with the 2A and I'm going to work my way from left to right. Everybody follow? So here's how it works. I'm going to take 2A and I'm going to times it by A squared. What's 2A times A squared? 2A cubed. What is 2A times 5A?
10A squared.
10A squared. And what's 2A times 7? 14A. Okay? So all I've done is take 2A times this, 2A times that, 2A times that. We okay? Everybody follow that? Anybody not follow? Please put your hand up when I ask you that. Don't be afraid. You don't follow what I did there? I took this value, I times it by A squared. So what's 2A times A squared? 2A cubed. 2A times 5A?
10A squared.
2A times 7.
14A.
Follow? Morgan?
Mhm.
So what do you think I have to do next now?
Type the 4 times the top.
Yeah, that's exactly what I have to do. Morgan, is that what you were going to say too?
I don't think so, but
I'm going to take the 4 now, and I'm going to times it by everything on the top.
okay.
Okay? All right, so here's the other thing that you want to know. I am going to do that. I'm going to take the 4 now, and I'm going to multiply it across the top. Okay? When I do that, I'm going to line it up with what I have already written out as part of my solution. So what is 4 times A squared?
4 squared.
So I'm going to put that right here. 4A squared. Notice I lined it up with the 10A squared. What's 4 times 5A?
28.
Where do you suppose it goes?
114.
Underneath the 14A. So what am I doing here? I'm lining up all my apples, my oranges, my pears. I'm lining them all up. Am I not? Because now I can simplify them when I'm done. Now I've got 4 times 7, which is 28. So now I simply add 2A cubed, 14A squared, 34A plus 28. All right? We just did that using numbers. We just did that using a method you learned in grade 5 and 6. It's the same method. To me, when I have a trinomial and a binomial, this is the easiest way to do it. Okay? Now, I'm going to show you a second method. You may like it better, and that's okay. But I'm going to show you a second method, okay? Any questions about this one? Yeah, Eli.
Do you always put like your first set of multiplication on the bottom?
No. I stack. The only reason I stack it this way because I want the trinomial on top and the binomial on the bottom. But it would have worked the same way. I just would have had 3 levels then.
Okay.
If I had changed it, I would have times this by this by this, and this by this. And it would have, it's one less level that I have to worry about. So I put my trinomial on top, my binomial on the bottom.
And if you had 4 on the top, would you put the
Put
4
all-
on top?
yeah.
Okay.
Yeah.
That's fine.
Yeah, no, it doesn't matter. You can do it both ways. Other questions about this method? Anybody? You okay now?
Yeah.
Yeah, good. Okay, so method number 2 works like this. The question said 2A plus 4 times
A squared plus 5A plus 7.
thanks. A squared plus 5A plus 7. Do we agree?
Yeah.
Okay, so there's my question. All right, pencils down for a second. I'm going to run you through the same method we began the class today doing. And that is simply this. I know that I have to take 2a and times it all by that. And then I have to take 4 and times it all by that, because that's what that says. I need to multiply 2a plus 4 through those brackets. So this is method number 2. And it works like this. I take the 2a in the first bracket, and I'm going to multiply it by everything in the second bracket. And then I'm going to take the 4 in the first bracket and multiply it by everything in the second bracket. So does this look similar to what we started class off today with? Putting a value in front and multiplying it through the brackets, does that look similar to what we did to start the day? Right? So now, I'm going to take this and multiply it through here. What's 2a times a squared? 2a cubed. 2a times 5a? 10a squared. 2a times 7? 14a. 4 times a squared? 4 times 5a? 4 times 7? Okay, did we do that to start the class today? We did exactly that. So what do you think is the last thing I need to do now? Gather the like terms. Couldn't said it any better. I have to gather the like terms. How many cubes do I have in there? Just one. So it stays as 2a cubed, right? Okay, 10a squared and 4a squared. What does that make? 14a squared. 14a and 20a make? 34a and 28. Is that what I just finished doing with my stacking method? Did I get that exact same thing? Yeah, I did, didn't I? Okay? You can use either method. I do not specify, I do not care, as long as you can do one of the two methods correctly. Okay? I'm just showing you both because some of you will like this, some of you will like the stack. Yes, Lily?
By the one on the bottom, did you just put those together which are the same?
Yes, that's exactly right. Yes. Okay, so far. How are we doing? Have we seen any of this before? Yeah, you have? Perfect. Okay. Now, we don't spend a whole pile of time doing a lot of binomial, trinomial stuff for trinomial by trinomial. We don't spend a lot of time. We do spend a pile of time doing binomial by binomial. And now there are 3 methods in which you can do binomial by binomial. The first 2 I just showed you. The third method is the one that I suggest you learn as well as you possibly can, and that's called FOIL. You guys know what FOIL is? Yeah, what does it mean? What are the acronyms? What do the letters stand for?
Outside, inside, left. Or,
You missed. It's not oil, it's foil.
I forget.
Yeah. Alright, you had the outside, the inside, and last.
I said front, right? Front.
First, yeah.
Oh, first.
That's fine.
First.
Yeah, I didn't hear the first part. All I heard was the oil part. Okay. Alright, so let's have a look here. Okay? This is the method you want to learn and understand because in the next section, we're going to work backwards. We're going to take a trinomial and we're going to have to factor it. So when we use FOIL, it means multiply. You're multiplying together. And FOIL only works for a binomial by a binomial. It's the only time you can use it if you have a binomial by a binomial. Everybody understands? Excuse me. Again, what I mean by binomial, 2 terms separated by 1 plus or minus sign. Fair enough? Okay? So, first, multiply the first in each bracket. That's what that means. So what's the first in each bracket? X by x, which is? X squared. Now the outsides of each bracket. X times 4, which is? 4x. The inside of each bracket.
3x times x, 3x.
And the last. 3 times 4, plus 12. Catch your like terms together.
X squared plus 12x. 7.
7x at 12. My outsides are the outsides of the brackets. 4 times x. Insides, 3 times x. Last in each bracket, that's what that means. Okay? We've done this before? Yeah? Alright, let's try a couple more. Okay, first in each bracket,
X times squared.
x squared. Outside,
X times negative
times 5, negative 5. So what is it? Negative 5x. And then inside, which is
2x.
negative 2x. And then last,
Positive 10.
plus 10. X squared minus 7x plus 10. Okay, so far? That's FOIL. What you're going to do in this unit is going to be massively important to you going ahead into 11 and 12. Factoring is used to solve multiple questions that you deal with what we call quadratic equations, which means an x squared equation, and we do it over and over again in applied and pre-calculus in grade 11. So you have to hammer this down, nail it down right in grade 10. Let it be easy for you here, because then it becomes very simple for you in grade 11 and 12. Okay? Questions so far about this?
Yeah, no,
You have to know it.
no, you have to know how to conduct the kind.
Yes. Like the FOIL method?
Yeah.
Yeah. You want to know how to do it. It's the easiest method of learning. What's that? You can. What's going to happen? All right. And that's perfectly fine. But the next like 5.2 is going from here to there. So using this method helps us understand how to find out the factors of this that add to give you that to get you to this. So it does help you. Your method will work, use it. If you're comfortable with it, use it. Okay? Let's try another one then. Okay, do that on your own. Okay. I don't even know if I saw one right. I think I did. Seth's got it right. So-
You didn't come to this side.
I haven't, no. So let's find out. Okay, I did see a couple of you use, using lines to show. I have no problem with that. I think that's all, like, a good idea. And what I mean by that is this. First is the first in each bracket, right? So, and I'm gonna pick on the ones that I did see. Dylan, what's 3W times 2W?
Apparently it's 5, but no, it's 6.
Alright, just checking. 6W squared. Alright, so there's the first. Okay, how many of us got that right? Okay. I'm gonna put 5. Okay, alright. Okay, so now the outside. Okay, now you look at these. Here's your first, your outsides are away from the middle. Correct? So there's your outside. So 3W times minus 9. That's minus 27W. How many of us got that? Okay,
So that's a 9.
that's a 9. What do you think it was?
An
A.
A.
A what?
An A.
Oh, sorry.
No.
That really caused me. Okay, so that's my penmanship, sorry. Okay, so now I need the inside. The inside are those two right there, right? So what's 2 times 2W? 4W. Okay, and then the last is 2 times negative 9, which is negative 18. Seth, watch what we're doing here. Because I don't think you had that right. Okay,
Wait, what?
what's wrong?
3 times 9? Negative
2
3.
times 7.
2
Oh, my
times
bad, my bad.
negative 9.
Sorry.
Okay, we okay? Alright, so now what I have, 6W squared minus 27W plus 4W.
Negative 23W.
Negative 23W. There was a number of you that had 31 there, so you have to watch your signage. Okay? And then minus 18. Who got that entirely correct? Roll, roll. Only 4 of us.
I put 31.
Didn't see the negatives.
Well, I didn't notice the.
It is to subtract. Alright. Take 2. Take 2. Take 2. One more. Try and write it out a little bit better.
Oh, I had it on real smart.
Alright. Everybody know what I wrote on the board there? No. It's not an upside down A or a B. It's a 6. Right? It's a 6. Promise. Okay. Alright, try again. First. Morgan, what's your first in each bracket?
4T times, no, 2T times 4T.
Okay,
Plus
write
one.
down the answer. What is it? What's 4 times 2?
8,
Good. And what's T times T?
T squared.
Okay, so you got 8T squared. You got that, right?
Mm-hmm.
Okay, what are the two on the outside of the brackets?
The 5 and the 6.
The 2 on the outside are away from the middle, Morgan.
Oh, 2t and -6.
There you go.
So it's times them together.
Yes, that's correct. So write that down.
Then the inside. So 5 times 4t. Wow. 5 times 6.
That's your signage. All right. No, we're not all right.
There's G's and plus signs all the same.
They got hooks on the bottoms of the T's.
I don't draw my T's like that, that's why. I'm my own person. A positive times a negative. It's a negative. Right. My plus signs and my T's look the same. You're around at point here. Makes it really confusing.
My A's and my T's look the same.
All right.
A's with that little.
Yeah, sure,
My combo out.
Okay, let's get going. What's the first in each bracket? I know it's first. That's why I asked. Okay, we'll jump right to it. The first in each bracket was 2t and 4t, right? 8t squared. All right, good start. Okay. What 6? Did you?
I kept adding mine on the last one.
Outside. 2t times -6. -12t. Inside. 20t. And the last?
-30.
Okay. Who did not have that?
I mean,
Cole, what did, well, I know you did. Cole, what did you not have there?
I just made a stupid mistake.
Okay. You know what your mistake is? Have you been making the same mistake over and over again? Just this time? Okay. You've been making the same mistake over and over again. Let's multiply, not add the first terms together. Yep. Got it. Okay. All right. So then what do I have? 8t squared
18,
plus 8t
-30.
minus 30. Who had it right?
Right?
Okay. Good. We're getting there. We're getting there. Good. Okay. I'm gonna leave the rest.
Oh.
We need another one?
Yeah.
Yeah.
So,
Okay. I got one for you. Okay. Let's see. This is a speed question.
Oh my god.
Nice.
Don't put T's and plus signs, it's not fair. It's not. Don't. I'm gonna do it. You want a pencil throwing, you don't you?
Go.
Oh.
Okay, well.
Rory, if you answer it in the next 4 seconds, you're wrong. She is not even close to being like me. Okay. I put this up here for a reason. Think you got it now?
Yeah, I know. That's not right.
Who in here thinks that they have solved this? Ken, you think so? You're making it easier than it actually is. Yeah. Cole, what are you thinking?
X squared 6.
X squared what? Sorry? Is there a sign in there anywhere?
Oh, this is, I'm gonna have to guess.
Okay.
I put -16 plus x squared.
Okay,
I
go ahead.
had 8 squared plus 64.
8 squared plus 64.
Yeah, but I'm wrong.
What?
Well, I was.
Is anybody else?
Is it not? Use the word duplicate. Yeah, it's squared.
Okay. I need everybody to settle, and you're going to answer a question for me, please. What is 2 squared?
4.
Okay, and how did you get 4? What'd you do? 2 times 2. Okay, excellent. How about 3 squared? 9. What'd you do? Okay. All right. And how do I get x squared? X times x. So then what do you suppose x minus 4 squared is? Not unsolved. No, it's not. There's no catching here. Don't talk.
Is it 2x squared plus 16?
No, here's the thing. Just think of the 3 questions I just previously asked you. What is 2 squared? And how did you get it? So you're telling me that you took 2 squared and said, oh, wait a minute, that's actually 2 times 2. Okay, and then I asked you what 3 squared is, and that's 9, and you said, that's because it's 3 times 3. So as soon as you saw the squared value, you multiplied it by itself. Did you not?
Yeah.
So what do you suppose I should have done here?
I get x will bracket x minus 4 and multiply. Like, just repeat it.
Yes.
Yeah.
What should have happened was this. And that, Rory, is why I said you wouldn't get it right in the first 4 seconds. Now, those of you that said x squared plus or subtract 16, that is completely incorrect, and that is the mistake that you'll make all the way through until grade 12 until you figure this out now. Okay? And it happens. You automatically just put that squared value through, and you'll do it in grade 12 pre-calculus. They will do it. When we use trigonometry, they do it. They don't know that it's the whole equation multiplied by the whole equation. So what does that mean? Well, what's my first here?
X squared
X squared. What's my outside?
minus 4x
What's my inside?
minus 4x
Good job, America. And what is my last?
plus 16
Plus 16. What is x
squared.
minus 4 all squared? X squared minus 8x plus 16. Brendan, go ahead.
In our last unit, wasn't it kind of similar to that, and you could just times it through like that, or was that?
You know what the difference is?
You times the exponents, right?
Yeah, but you know why? There was no subtract sign in the last unit.
So if that would, even if that was an adding, so it still doesn't matter.
The reason we did it in the last unit is you would have had this. No subtract or add sign in there.
Okay.
And then you would have done exactly that. Because that add sign's in here, that or the subtract sign in this case, that changes the whole dynamics of the question. Does everybody follow what I did there? Does everybody understand what I did there? Because that's why I asked you the questions that I did. What is 2 squared? What is 3 squared? What is 4 squared? Well, you take that value and you multiply by itself, correct? In each case. So when I say what is x minus 4 all squared, you multiply x minus 4 by itself. And when you do that, you have a binomial by a binomial. You FOIL it, you end up with x squared minus 8x plus 16. This is called, this will be important to you as well as we get older, this is called a perfect square trinomial. And what that is, a perfect square trinomial is this value, this is grade 11 applied now, so you don't need to worry about it. Ooh, that missing value right here that I just erased again and again, 16. That value there comes from half of this value squared. What's half of 8?
4.
And what's 4 squared?
16.
That's why it's called a perfect square trinomial. Okay? Alright, so that you just learned some grade 11 applied just now. But you do have that question in your book. And again, I FOILed it. So if you look at page 87 right now, they say in question 2, use algebra tiles. I don't want you to. Use the method that you like best. I prefer FOIL because it makes the next section easier. However, if you want to use your distributive property, go ahead. If that's easier for you. Seth, if you want to stop that and stack it, go ahead. Stack it. Yes. That's correct.
Okay, so for all these maybe?
Okay? Cole, go ahead.
There's one thing I really do wanna learn, and that's how to simplify it. Like, I know how to get to the x squared minus 4, but how do we get to the x squared minus 8?
I add these two together because they're both x's.
Oh, okay.
So I'm collecting the like terms. I can't change them, but I can add them together when they're the same.
Oh, that's.
Does that make sense? All right, you have 30 minutes right now to go through all of 5.1. I want you through it. But you got multiple choice in there. Okay. Remember, get to the applied part. You don't have to. I don't want you to. I don't want you to do it.